Set for linear relationships, we're going to find rules today using a table of values. So last lesson, we had a look at graphing some linear relationships. I gave you the rule, we filled out the table, and then we graphed it. So we're going to do it backwards today. This time I'm going to give you the table and you're going to find the rule. Okay, so if you have a look at this table that we've got here, it's all about finding patterns. Now, what's happening up the top is that each of these numbers are going up by 1, okay, which is what we want. They're all going up by 1. Now, when x's are going up by 1, what's happening to the y's? Well, they're actually going up by 2 every time, okay? Each of these numbers is adding on 2, and if you add on another 2, 11, 13, etc. Okay, so we're adding on 2 each time. Now, that's really important because you'll find that the number that we add on each time when our x's are going up by 1 is actually the coefficient of x. Now remember, coefficient is the number in front of the x, and we're going up by 2, so that number in front of our x is the number 2. That's what we multiply by. Whatever we're going up by is the number that we're timesing x by. So we're timesing x by 2. Now the number on the end, plus 3, actually comes from when x is 0. If you have a look here, when x is 0, y is 3. And that's because that's our adjusting number we need to add on the end, if you like. Because if you think about it, we're timesing everything by 2. So let's take our 0 and times it by 2. Now 2 times 0 is 0, because anything times 0 is 0. However, our y value is 3. So how do we get from 0 to 3? Well, we have to do this adding on 3. So these two numbers here, the 2 and the 3, simply come from 2 is the number that we go up by, the y's are going up by, and the 3, the number on the end, our constant term, is the y value when x is equal to 0. Okay, and that's basically how you can determine any rule. Now, obviously, this is only going to work if x is going up by 1. Okay, you need your x's to be going up by 1. If they're not, you may have to adjust them, but you will find that most of the time they are. Okay, let's move along and have a look at some examples. All right, so in this one, same thing again. Our number in front of our x, so in this case it's minus 2, is what our y is going up by. Or in this case, it's actually going down. So 5, 3, 1, minus 1, 3. What's happening each time is they're going down by 2. Okay, so that's our number that we're timesing by. We're timesing by -2 because they're going down by 2 this time. And our number on the end, our constant term, plus 3, that is again coming from when x is equal to 0, what is y equal to? And that's going to be the number 3. Otherwise known as the y-intercept when you go to graph it, the y-intercept will always be this number on the end. What I mean by that is if you're to graph, here's our y-intercept, 1, 2, 3. This graph is actually going to go through this point. So when y is equal to 3, x is equal to 0. So our line's going to look something like this. Okay, let's do these together. So find the rules for the linear relationships described in the tables of values and graphs below. First thing you need to check is the top going up by 1? 0, 1, 2, 3, 4. Yes, it is. Perfect. Okay, so what is the bottom going up by? Well, in this case, it's actually also going up by 1. Okay, plus 1, plus 1, plus 1 each time. So y increases by 1. So 1 is the number that goes in front of our x. So when we write our rule, it's always going to be y equals something times x and then plus something on the end. All right, or it could be minus something on the end if it's a negative number. But there's basically two somethings you need to fill in. You need to fill in what's the number here that we multiply x by, and what's the number that we add on the end, or sometimes subtract. Okay, so two numbers we need to fill out. Now, the one in front of the x, the coefficient of the x, comes from the number that we go up by, the number the y's are going up by when x is going up by 1. Now, in this case, it's also 1. So I'm going to write 1x in front of my x, And then some of you are going to tell me, well, I don't really need to write the number 1, so I'm going to get rid of it and just write x. So y equals x plus, now I'm still needing this number on the end. The number on the end comes from when x is 0, what is y? So when x is 0, y is 2. So that's going to be my number on the end. All right, and there's my rule. My rule is y is equal to x plus 2. Now we can test this. Here's my rule here. Y equals x plus 2. Whatever x is, we add on 2. Does this work for every number in my table? Well, let's add 2 to 0, we get 2. Let's add 2 to 1, we get 3. Let's add 2 to 2, we get 4. Let's add 2 to 3, we get 5. And if we add 2 to 4, we get 6. So yes, my rule works for everything in the table, which is excellent. Okay, so when x is 0, y was 2. All right, and you can see that these two numbers, the 1 goes here in front of the x. It's an invisible 1 because I'm not actually going to write 1x, I'm just going to write x. And the 2 becomes the number on the end. Okay. All right, let's do our next one. Here's our next table. First thing you need to check, is x going up by 1? And the answer to that is yes. Perfect. So now we can have a look at what y is. So what's happening to y each time? Are they going up or are they going down, and by how much? -1, 2, 5, 8. They are adding on 3. Okay. So when x is going up by 1, y is increasing by 3 each time. So that's our number that is going to go as our coefficient of x. That's the number that goes in front of our x. So remember, our rule is always y equals something times x plus something on the end. Okay? This something times x is the number that y increases by, so I'm going to go ahead and put my 3 in that box. All right, the number on the end comes from when x is 0, what is y? When x is 0, y is 2. So x is 0, y is 2. 2 is my number that goes in my box. And here is my rule. Y equals 3x plus 2. Okay, so the number y goes up by is the number that goes in front of the x. And the number that y is when x is 0, which you can see here in your table, x is 0, y is 2. That's our number on the end. Okay. All right, this time we don't actually have a table. We've got it as a graph. But we still need the same two things. We still need to know what y is increasing by when x goes up by 1. And we still need to know when x is 0, what is y. Okay, there are two pieces of information we're trying to find. So let's have a look at this graph. Y increases by, all right, as x goes up by 1. So you'll see each time we go across a box, that's x going up by 1. So here, x is -1. Here, x is 0. Here, x is 1. And if we could see another one, which we can't, there, x would be 2. Okay, so at each of these points, we're going across one box, across one box, across one box. So x is going across by 1. What's y increasing by? What are we going up by? So as we go across one, what's y increasing by? Y is going up 2. X goes across 1, y goes up 2. X goes across 1, y goes up 2. So as x increases by 1, y increases by 2. Okay, so x is going across 1, y is going up 2. So y is increasing by 2 for every 1 that x increases by. Okay, so y increases by 2. Now, what did we do with that 2? Remember, the one that y was going up by is the number that goes in front of our x. Okay, so y equals something x plus something. All right, this number 2 is the number that goes in front of the x. So in this case, y equals 2x. All right, we need our number on the end. Now, how did our number on the end happen? Well, it happens when x equals 0. What is y? Now, remember before I mentioned to you that's actually the y-intercept, because when x equals 0, just here, you're actually on this line here. So everywhere along here, x is equal to 0. Okay, so x is equal to 0. here, what is y equal to? Well, y is equal to 1, just there, that point. So x is 0, y is 1. So we're looking at this point just here. So when x is 0, y is 1. That's what I call my y-intercept, because that's the point where the line intercepts the y-axis. All right, so when x is 0, y is 1, that's my number that goes on the end of my rule. And here is my rule, y equals 2x plus 1. Okay, last question we're going to do together. Y increases by what as x goes along 1? So as we jump along one box each time, what's happening to y? All right, so from this point to that point, x has gone across 1. What's happened to y? It's actually gone down 1. X goes across another one, y goes down another one. X goes across another one, y goes down another one. X goes across 1, y goes down 1. X goes across 1, y goes down 1. Okay, so y is increasing by, well, it's not actually increasing, it's actually decreasing. So y increases by -1. Okay, so -1 is this number that goes in front of our x. So our rule is always y equals something times x plus something on the end. All right, what y is increasing by when x goes up by 1 is the number that goes in front of my x, okay, the coefficient of x. Now, I'm not going to actually write -1 because we don't write -1x, although technically that's still right. We don't write the 1, so I'm just going to write -x. So y equals -x plus. Now, the number on the end is the y-intercept. At what point does this line intercept with the y-axis? Well, it's actually this point just here. So at that point just there, x is 0 and y is 2. So when x is 0, y is 2. So that's going to be my number that goes on the end. All right, and now I have my rule here, y equals -x plus 2. Okay, you can go ahead now and do your set questions.